Hello, good morning, everybody. Mr. Chu. So this is my second video for the semester 1, chapter 1, where in this video, we're going to discuss about compounds and isotopes. Are you ready? All right, so previously, we have already had a look at the content of element. Okay, so a little bit summarized from what we have learned previously. So we know that element can be generally categorized as three, where we have metals, which is defined as a class of substance characterized by high electrical and thermal conductivity, as well as malleability, ductility, and high reflectivity of light. Whereas we have another elements which is also known as metalloids, which is an element that exhibits some metals and some non-metal properties. So metalloid form a jagged region in the periodic table separate from elements which have clear metallic properties from elements which has clearly non-metal properties. And finally, we have a non-metal, which is defined as the most lacking of distinctive metallic properties as they range from colorless gas like hydrogen to crystal-like iodine. So we have already learned about the properties of elements. So we are going to continue with the next one, where we are going to learn about compounds and also isotopes. So most of our natural occurring substances exist in the form of either two or more elements that combine through chemical bond. In fact, only a few elements that occur freely in nature, which are mostly located at group 18 of the periodic table, such as helium, neon, argon, krypton, and xen, that occurs in air as a separate atoms. However, there are also some elements that exist naturally as diatomic in polyatomic nature, such as hydrogen, H2, nitrogen, N2, oxygen, O2, and all halogens, F2, Cl2, Br2, and I2. While phosphorus exists as P4, sulfur exists as S8. Now, as these elements do not exist in a free form, as the electrons of atoms interacting with the elements that are involved in the compound formations, so element can combine generally in two ways. Either they transfer electrons from the atom of one element to another atoms to form ionic compounds, or they can share electrons between atoms of different elements to form covalent compounds. So these processes generate chemical bonds the force that holds the atoms together, the elements of the compounds. So let's have a look together. How is the formations of ions? So as we already know that elements can be generally categorized as metal and non-metal, and I will put metalloid as also a non-metal. So when an element donate electron, they will form positively charged ion. So most of the time, these elements are usually metals. Okay, so for example, we have we say that group 1 elements form +1 charge, where sodium donated 1 electron to form sodium ion, or potassium donated 1 electron to form potassium ions. As for group 2, all of them form a metallic ion of +2 charge, where, for example, magnesium donated 2 electrons to form magnesium 2+, whereas barium donated 2 electrons to form barium 2+. Group 13 forms +3 charges, such as aluminium form Al3+, and some of the gallium can also donate the 3 electrons to form gallium ions. Whereas on the other part, we have elements when received electrons will form a negatively charged ion, which is also known as anion. So for example, when nitrogen accepted 3 electrons, will form nitrite ions. Okay, so note that there is a changes in name from nitrogen to become nitrite ion. Phosphorus, when accepted 3 electrons, will form phosphite ion, P3-. Whereas in group 16, you have oxygens. Oxygens receive 2 electrons to form oxide ions. Sulfur accepted 2 electrons to form sulfide ions. Whereas group 17, we have chlorine accepted 1 electron to form chloride ion. Bromine accepted 1 electron to form bromide ion. Now, of course, in here, because I just want to expose to you the formations of the ions, but we also cannot neglect the fact that their nature of the atoms or the elements involved. For example, in nature, oxygen exists as O2. So that is why instead of accepting 2 electrons, you accept 4 electrons to form 2 oxide ions. All group 17 exist naturally as a diatomic elements. So for example, Cl2. So one chlorine accepted 1 electron to form one chloride ion. So two chlorine accepted two electrons to form two chloride ions. Same goes with bromine, which accepted two electrons to form two bromide ions. There are also some other examples of the elements and compounds that can form ions, and here are a list of the compounds which forms different type of the ions. And as STPM students, you are really required to understand some of these ions and its formula. So, for example, we have iron. Iron can exist as iron 2 and iron 3. Now, for this kind of elements that can exist more than one oxidation state, usually to represent the formation of the ion or to name the ion, we will put the Romantic letter that represents the charge of the ions itself. For example, if iron has the donated 2 electrons to form Fe2+, so you put as iron 2 ions. If iron were to donate 3 electrons, you form iron 3 ions. So same goes with chromium that donates 2 electrons to form chromium 2 ion. Chromium donated 3 electrons to form chromium 3 ion. Lead when donated 2 electrons to form lead 2 ions. Lead when donated 4 electrons to form lead 4 ions. Copper donated 1 electron to form copper 1 ion. When donated 2 electrons to form copper 2 ions. Tin donated 2 electrons to form tin 2 ions and donated 4 electrons to form tin 4 ions. Manganese, similarly, donated 3 electrons to form manganese 3 ion and donated 4 electrons to form manganese 4 ions. So for all these transition elements and also some of the elements, especially in group 14, where they can exhibit more than one oxidation states, you have to put the Romantic letters that represents their oxidation states or the charge that is attached to them. And then last but not least, we also have the molecular ions, which is positively charged, where we have NH4, which is named as ammonium ion. Whereas for the negatively charged elements, okay, we have, for example, hydrogen, when accepted 1 electron will form hydride ions. Okay, and then we have some also what we so-called as an oxo anion. We have nitrate. We have hydroxide. By the way, hydroxides, the negative should be located at the O, not at the H in here. So this is the correct way to write hydroxide ions. Yeah. Okay, then we have cyanide ion. Right. We have cyanide ion. We have thiocyanate ion. We have manganate 7 ions, excuse me. We have chromate 6 ions. We have dichromate ions, 6 ions. We have carbonate ions. We have bicarbonate or hydrogen carbonate ions. We have sulfite ion, SO3 2 minus. We have thiosulfate ion, H2O3 2 minus. We have sulfate ion, SO4 2 minus. We have hydrogen sulfate ion, HSO4 minus. We have phosphite ion, PO3 3 minus. And we have phosphate ion, PO4 3 minus. And then we can also have hydrogen phosphate ion, dihydrogen phosphate ion with the formula HPO4 2 minus and H2PO4 minus respectively. And then we can also have peroxide ion with the formula O2 2 minus. We can have superoxide ion, O2 minus. We can have hypochlorite ion, ClO minus. We have chloride ion, ClO2 minus. We have chlorate ion, ClO3 minus. And we have perchlorate ion, ClO4 minus. Now, as for these ions, especially when they involve group 17 elements, sometimes you can see that their chlorate ion is written as oxidation state, where they are named as, for example, hypochlorite ion is sometimes also known as a chlorate 1 ion. Okay, chlorate ion, sometimes also known as a chlorate 3 ion. Okay, and you have chlorate 3, then you put the oxidation state 5, and then perchlorate ion, also known as a chlorate 7 ion. So this is sometimes how they are put if they were to name in the oxidation states. So as a STPM students, you should be able to remember some of these basics hydroxonium oxo anions in here. Then Why is it important for you to learn about the formula of the ions? Because when a positive ions meets with a negative ion together, they will form what we so-called as an ionic compound. Are you ready? So let's have a look at a way of how ionic compounds are formed here. So ionic compounds will form with a formula where you have AX plus of Y, BY minus of X. What does it mean? So for examples, if let's say you have A plus and X minus, okay, so because usually we don't write 1 for 1 plus, 1 for 1 minus, okay, we don't write that, so usually we just put plus and also minus. So in here, since you have 1 plus, okay, the formula will sort of like crossed between here, so you have the formula AX, okay. If let's say you have the next example, let's say we have A plus and Y2 minus, okay, so you have A plus going to here and Y2 minus going to here. So therefore, you have the formula of A to Y. Last but not least, when you have the formula of Z minus in here, Z3 minus in here, so you have 1 plus and 3 minus goes to here. Okay, so you get the formula of A3Y in here. So do you think you understand? Okay, so together with A plus and X minus, you form the formula AX. With A plus and Y2 minus, you form the formula A2Y. With A plus and Z3 minus, you form the formula of A3Z. B2 plus reacts with X minus to form the formula BYX2. B2 plus react with Y2 minus to form BY. B2 plus react with Z3 minus to form B3Z2. Whereas for cation with the formula C3 plus, if you react with X minus, you form CX3. If you react with Y2 minus, you form C2Y3. And when you react with the Z3 minus, you form CZ here. So these are how the formula of the ionic compounds can be generated based on the charge of the respective cation and also anions in here. Then we also learned that covalent compound form when elements share electrons, which usually occur between nonmetals. So even though relatively a few nonmetals exist, they interact with many combinations to form a very large number of a covalent compound. So here are a few examples of a typical covalent compound that will for sure we come across as we learn deeper and deeper in Stpm syllabus. Okay, to the most common carbon dioxide, water, ammonia, hydrogen chloride, methane, carbon tetrachloride, hydrogen peroxide, sulfur dioxide, phosphorus trichloride, ethanol, ethanoic acid, hydrogen sulfide, nitric acid, carbon monoxide, benzene, formaldehyde, propanol, ethene, sulfur hexafluoride, dinitrogen tetraoxide, phosphine, silicon dioxide, methylamine, sulfur trioxide, nitrous oxide, phosgene, dichloromethane, hydrogen iodide, dinitrogen tetroxide, ethyl ethanoate, hydrogen telluride, chloroform, sulfur tetrafluoride, phosphorus tribromide, hydrogen selenide, and boron trifluoride. As the time passes, don't worry about it. You will for sure get to meet all these examples of compounds. And when it comes to the chapter 3 later, we will for sure learn on how to draw the Lewis structure of all these covalent compounds. So do not worry too much about memorizing all these formula, as you are not really required to memorize all this. So here are the introductions towards what is an ionic compound and what is a covalent compounds in here. All right, so we are going next to the next subtopic. We're going to learn isotopes. So before we learn more about isotope, let's together first define what is an isotope. So an isotope is defined as atom of given element do not all have the same masses. Most elements have two or more isotopes. Atoms. What is an isotope? And isotopes is defined as, I'm going to highlight this, atoms that have the same number of proton or atomic number, but different number of neutron or mass number. Okay, so as you can see here, proton number is also known as atomic number, and number of neutron is also known as the mass number in here. So here are typical examples of isotopes for hydrogen. Hydrogen can exist as what we so-call as a protium, which is hydrogen 1. We can have hydrogen 2, which is also known as deuterium. We can have hydrogen 3, which is also known as tritium. Now, the difference between hydrogen 1, hydrogen 2, and hydrogen 3 is described in the table and the diagram below. So all of them share the same number of proton, which is 1 proton in here. Okay. However, their mass number or nuclear numbers are different. So hydrogen 1 has mass number 1, hydrogen 2 has mass number 2, and hydrogen 3 has mass number 3. Okay. So eventually, if you were given the number of the mass number and the atomic number, you can eventually calculate the number of neutron where you subtract mass number with the number of neutron. So 1 minus 1 you get 0, 2 minus 1 you get 1, 3 minus 1 you get 2. So how does these elements or how does this isotope represents in the form of the symbol of elements? Usually we write hydrogen 1 as hydrogen 1, 1, hydrogen 2 as hydrogen 2, 1, hydrogen 3 as hydrogen 3, 1. Coming together with these informations is what we call as a percentage of abundance. So what is actually a percentage of abundance? A percentage of abundance is the what we so call as a percentage of the elements of the isotopes occur naturally. Okay. Okay, so what does 99.985 of hydrogen 1 stand for? Now, let's say if we have 100,000 of the particles here, so we will say that hydrogen 1 will occupy almost 99,985. Hydrogen 2 will occupy probably about 14, and hydrogen 3 will occupy probably 1. Right, so that is what percentage of abundance means here. Okay, so from here you need to understand why is it that certain isotope has a high percentage of abundance and certain isotope has a low percentage of abundance. So the isotope with a high percentage of abundance indicates that it is the most stable form of the atoms that can be found naturally. Okay, whereas the isotopes with the lowest percentage of abundance, we say that it is an unstable isotope because it has a short half-life and tends to disintegrate. So showing here are the comparisons between the similarities and the difference between isotopes. So some of the similarities of the isotope that we can see here, as you can see from the table just now, they have the same number of proton. Some number of protons also known as a nuclear charge, and also number of electrons, or they have the same valence electron. Now, we are going to talk about for neutral atoms, not ions, right? Okay, and then in terms of atomic radius, they have the same atomic radius, since they have the same number of proton and electron, and therefore the same chemical properties. Whereas the differences between all these isotopes are definitely they have different number of neutrons, hence different nuclear number. They have different physical properties now because masses influence some of the basic physical properties such as the atomic mass, density, and even melting point, boiling point is sometimes influenced by isotopes. And of course, different isotopes have different half-life and also stabilities in here, right? So the information of the percentage abundance allows us to calculate the relative atomic mass of an element, which is defined as the average of the summation of isotopic mass of all isotopes multiplied by the percentage of abundance, where we are going to look into details in our next video, right? And before we end these sections of the video, allow me to show you some more other examples of isotopes. So, for example, oxygen can exist as three isotopes of oxygen 16, 17, and 18. So you can see from here, you have the proton number 8, mass number of 16, 17, and 18 respectively, and number of neutrons of 8, 9, 10. So they also have different percentage of abundance. For example, oxygen 16 has the percentage of abundance of 99.76. Oxygen 17 has the percentage of abundance of 0.04, and oxygen 18 has the percentage of abundance of 0.20. Now, these informations are important for us to calculate later part the relative atomic mass of the elements involved. Chlorine exists naturally as two isotopes, namely chlorine 35, chlorine 37, with the different number of neutrons and also percentage of abundance. And then finally, uranium. Do you think you can fill in the blank by yourself? So, as you can see, uranium-234 has the proton number 92, mass number of 234, hence the number of neutrons as 142. As for uranium-235, you have proton number of 92, mass number of 235, therefore the number of neutrons is 143. And uranium-238, which is the most stable, will have the number of protons of 92, mass number of 238, and number of neutrons of 146. So with that, I'm going to stop my video today, and I'll see you all in the next video. Thank you.